Jumping back into extra math 2, so I've already done 10 through 3. 2 more tests left. I'm getting it from this link up above here. Let's jump into number 7. This is going to be more advanced problems on average. So number 7, I see x to the a squared divided by x to the b squared is equal to x to the 16. I want to remember that when I divide bases, I subtract exponents. So I should be able to do x to the a squared minus b squared is equal to x to the 16. So I just use that simple principle, and I should be able to reduce this even more. If everything here has a base of x, then it's not really meaningful to have it, right? So I could actually say a squared minus b squared is equal to 16. And then here's where knowing our sum and difference or a difference in squares can really help. I can go a step further and I can say a plus b times a minus b is going to be equal to 16. And then, you know, in the kind of SAT manner, they do give me one of these. They give me a plus b is equal to 2. So I know this is 2. So 2 times a minus b is equal to 16. I can divide both sides by 2. Divide by 2. Divide by 2. And finally, we have a minus b is equal to 8. And they ask for a minus b. So we get a for this one. Really good practice problem. Exponent roles, we have our sum and difference roles. A lot to incorporate here. I'm gonna get rid of this bit for the bottom part here. So for this next question, this is gonna be another classic role. They're only gonna ask you really 2 or 3 types of I questions. This is the hardest I question they can ask you. There is one single I question I've seen. It's either on this test or the next one, so make sure to stay tuned for that. 99% of the time, this is the hardest. What you'll see is you'll see I's on top and I's on the bottom, and you want to multiply by an 8 minus 2i and an 8 minus 2i. And what this does is it gets rid of your i's in your denominator. It's always going to be the same thing. It's just a foiling problem, but let's make sure we get the right answer. So if I FOIL this out, I should get 24, right? Minus 6i, minus 40i, plus 10i squared. So you're always going to get an I squared. Just remember that that's negative 1. So let's simplify the top before I do the bottom. Actually, I can do the bottom, then I'll simplify both. So on the bottom, we get 64 minus 16i plus 16i. So right there, that's why everything ends up canceling out on the bottom. And then minus 4i squared. Remember that that's negative 1. So let me write my kind of final numerator denominator. So this is going to be minus 10. So that should be 14. That and that. And then I get a minus 46 I squared, right? Or no I squared, just I. And on the bottom here, I should get, that's going to be plus 4, right? So 68. And I think that's it, just 68 on the bottom. So, okay. So is there anything else we can do? Plus negative. So I want to see if I can maybe try to reduce this. It looks like I can divide everything by 2 because everything's even. So this would now become 7 minus 23i divided by 34. And I just look through my answers and I think I see 7 over 34 and 23i over 34. So they just separated the numerator values. This one, you're always going to see the same thing. Multiply by my denominator, just switch the signs. So if I get 8 plus 2i on the bottom, you multiply by 8 minus 2i to both top and bottom. Not too bad. Number 12, another really good problem here. I'm just going to get that out of the way for the future. And number 12, this one might look like it's on the easier side because it's just a basic equation, but it is a little tricky. So we calculate this value up above. Which of the following, so I just glanced at my answers. They're just solving for f, right? So it could be challenging because there are 2 f's, but we still always want to try, start this out the same way. I cross multiply and I get f is equal to nr plus fr, right? And since I'm solving for f, I might as well get everything on the same side that has an f, right? So if I get f minus fr is equal to nr, and then I'm going to want to take out my f. So this is where the little weird factoring part is. If I factor out an f, I get 1 minus r is equal to nr, and then divide both sides by 1 minus r. And that should be Rn over 1 minus r. I think B for this one, yeah. So a little bit tricky with some of the factoring and cross-multiplying. But yeah, we get f, all the f's on the same side, factor the f out, and it's actually not too bad. So let's keep going. What about, well, this is just an entirely good page here. What about number 13? So for 13, what is the sum of all the values of m that satisfy that? So this is a weird one. I could probably just throw this in Desmos because it looks like I'm going to get really weird answers. So I'll have to use my calculator kind of in tangent with it. So if I pull up my Desmos here, and that should probably make this a little bit easier than using, you know, my quadratic formula. So let me just throw this in here. I'm going to replace them with x's. So this to the second minus 16x plus 8. So it's not going to be nice numbers. So my two solutions I get here are those two. So I'll write these two down. 0.5359 and 7.4641. Okay. So if I have these two, let me just make sure I typed everything in right. Minus 16 plus 8. Okay, the sum of all values. Okay, so let's get rid of Desmos now. So the sum of all values that equal this. So I think I would just add these two together. 0.53. 0.5359 plus 7.4641. So you actually should get an exact 8 here. So this one, when it was on the no calculator section, was a little harder because you had to use your quadratic formula. With Desmos, this would be an easy problem now. Not too bad at all. Now this one's really good. So this is a super good problem. One of my favorites. Let's go ahead and move it over a little bit. So when I look at this, we have 0 or O is the center of the circle, and the measure of AOB, so that's going to be this guy, that's going to be pi over A radians. What is the value of A? So I wonder, there could be other ways to solve this. I think there's a very easy way to solve this, and that is to remember the principle that similar triangles have equal angles. Right? So if I have two right triangles and one is 3, 4, 5 and one is 6, 8, 10, when I do sine or cosine, I'm going to get the, a multiple of the numerator, a multiple of the denominator, and I'm still going to get the same angle. So like if I took sine of this angle here, I would get 8 over 10. Or if I took sine of this, it'd be 4 over 5. This reduces to 4 over 5, so I'm going to get the same thing. So if I can ever make a multiple, or if I could divide my sides by a certain number to make my sides look more relevant, then that can always really help me. Square root of 3 and 1 might not be the most clear to you, but if I throw them over a 2, does this make you think of anything? I know the unit circle isn't required for the test, but for little problems, little harder problems like this, I think it really helps. I will show how to do it without having to use the unit circle, but as soon as I see that I've square root of 3 over 2 and 1/2 for my x and my y, so this means my x is going to be bigger than my y, so I try to think of when, what type of angle on my unit circle. There's only going to be, let me make it a little bit more clear. So off to the side here, I'll do like my first quadrant of my unit circle. So there's only actually a few numbers you have to know for this, right? There's going to be your 30, your 45, and your 60. So remember that your 45 is going to be really unique. That's going to be square root of 2 over 2, square root of 2 over 2 for your x and your y. And then these two are going to rotate between square root of 3 over 2 and 1/2. So the way to remember it is that square root of 3 over 2 is bigger. So when my x is bigger, what type of angle is that going to form, right? So if this is my 30 and this is my 60, the 60 is going to mean that my y is bigger. The 30 is going to mean that my x is bigger. So I already know that this is going to be a 30-degree angle because I know the square root of 3 over 2 is my x. So if it's a 30-degree angle, we just want to remember our pi's now. So if this guy up here is pi over 2, and I just rotate, 3 times to get up to pi over 2 divided by, pi over 2 divided by 3. Pi over 2 divided by 3 should get me pi over 6, or a is equal to 6. So in my opinion, I think the unit circle, it's not a lot to memorize because there's literally only 3 numbers that you have to know. Square root of 3 over 2, 1/2, and square root of 2 over 2. They can help you. I've also seen it kind of help with like those 45-45 triangles. If you ever did forget your triangle identities, this would help too. To maybe solve it without it, let's see. I think it's super easy to solve that with the unit circle. Let's see what we could try to do. So I could maybe make my x and y. So let's set up a new triangle up here in the top left. If I set up a nice triangle here, like this. Oh yeah, we can solve it without using the unit circle. So look, if I make this my x and my y, if I make this 1, and I make this square root of 3, and I need to do a SOHCAHTOA because I also care about this angle. So it's always about identifying the 3 things we want to know. If I make this z, if I say tangent of z is equal to opposite over adjacent is equal to 1 over square root of 3, this actually might be a little bit easier than memorizing the unit circle because now I just take the inverse tan of 1 over square root of 3, and it should get me z. So z here, I think that would give me 30 degrees. So you should, if your calculator's in degrees mode instead of radians mode, you should get 30 for z. And then just remember to turn this into radians. We use our translator. So for every degrees, for every 180 degrees, we have pi, right? So if I am dividing this by 6 to get to 30, I should divide this by 6 to get to pi over 6. So I would say these actually feel about even to me. I think both are fine. This kind of proves you don't need the unit circle to solve this. I think that's good for now. That's a really good start. Those were kind of tough problems to start with. So we'll jump back into extra math 2 on the next one.